influence of magnesium precursor types on morphology, structure, transmittance, and energy band gap of zinc magnesium oxide films obtained by spray pyrolysis. The exceptional optical properties of zinc oxide have enabled the development of various optoelectronic devices. On the other hand, zinc oxide films have demonstrated behavior such as arbitrary emission laser in microcrystalline films and room temperature polarized lasers, lighting emitting diodes, and solar cells. While zinc oxide has been extensively investigated, lesser research has been conducted on the properties of the magnesium zinc oxide alloy. Films of magnesium zinc oxide have been studied through the different methods including magnetron sputtering, Sol-Gel, pulsed laser deposition, chemical vapor deposition, and spray pyrolysis. Among these, spray pyrolysis is the attractive for the present study as it allows for the production of large area films with good uniformity at low cost. Thin films and nanostructure of magnesium zinc oxide, including nanocrystals and core shell structures, have been recently investigated with the aim of obtaining a family of alloys that enable tuning the band gap and photoluminescence emission in the ultraviolet range. In studies of magnesium zinc oxide films using spray pyrolysis, the predominant crystalline structure is the hexagonal Wurtzit V4 phase, even up to the 30 magnesium concentration, with a band gap ranging from 3.37 to 3.70 electron volt, depending on the magnesium concentration. Beyond 30 magnesium concentration, the cubic rock salt phase is observed. Furthermore, the emission from these films has been recorded in a range extending from the ultraviolet to orange wavelength. In the current study, the morphology, structural, and optical properties of magnesium zinc films prepared by spray pyrolysis with magnet contents of 0, 10, 20, and 30% atomic were investigated. Two types of magnesium precursor have been studied: magnesium acetate and magnesium chloride. The prepared solution was sprayed on the quartz substrate, heated at 400 Celsius degree for 60 minutes, with nitrogen carrier gas flow rate of 4 liters per minute. Before the films were deposited, an annealing treatment were made in a horizontal furnace at 350 degrees Celsius for 3 hours. A scanning electron microscope has been used to study the surface morphology of the films. Energy dispersive spectra were investigated to control the film's composition with the increase of magnesium concentration in the films. In the X-ray diffraction patterns, peaks 100,002 and 101 at 31.79 degrees, 34.44 degrees, and 36.28 degrees have been detected. That confirms Wurtzit crystal structure. As magnesium content increases in zinc oxide films, the X-ray diffraction peaks shift to higher angles, such as 34.44 degrees to 34.68 degrees due to the decrease of the interplanar distances in magnesium zinc oxide crystal lattice, owing to the smaller ionic radius of the magnesium compared to the zinc one. For the study of optical properties, transmittance and photoluminescence techniques were used. The transmittance spectra were analyzed in the range of 200 to 800 for both magnesium precursors. The value of optical transmittance in studied films was about 80%, This value is important for transparent conductive oxides in the device applications. Another important result is related to the shift of the absorption edge to shorter wavelengths from 352 to 285 nanometers for acetate magnesium precursor and 377 to 325 nanometers for chloride magnesium precursor. Peculiarities of structure and optical properties of magnesium zinc oxide films, different magnesium precursors are discussed in this work. For conclusion, a comparison was made between the precursor magnesium acetate and magnesium chloride for the production of magnesium zinc oxide films using the spray pyrolysis technique. Non-destructive characterization techniques were employed, confirming that the acetate precursor is the preferable candidate for study due to the various factors. Primarily, it was found that the film's transmittance had a percentage of 85%. The tau technique was used to determine the band gap for each sample. The samples varied in magnesium content from 10, 20, and 30%, and zinc oxide sample was included for comparison. The tau result revealed an increase in the band gap value. The highest value recorded was 44 electron volt for the magnesium sample with 30% of content magnesium. In contrast, for chloride samples, the shift reached up to the 3.9 electron volt. X-ray diffraction was employed to examine the crystalline structure. In the crystallographic direction 002, it was observed that the incorporation of magnesium into the lattice was occurring. This is evident from the position of this direction, showing a shift towards higher angles as the magnesium content increased. Similarly, photoluminescence showed alterations in the near band edge and the band associated with defects.